You spend an hour feeding PDFs into an AI chat window, carefully building up context to analyze a complex problem. Then you start a new chat session. Instantly, all that carefully constructed knowledge is wiped out. The AI starts completely from scratch. To solve this, we are going to build an LLM Wiki. Instead of treating the AI as a temporary chat interface, we will configure it to act as an active, persistent bookkeeper on your local machine. By the end of this tutorial, you will have a local directory structure. When you drop a new file into it, the AI automatically reads the text, writes a detailed summary, cross-references your existing notes, and logs the update. You handle the sourcing and decide what questions to ask. The AI handles the endless filing, tagging, and folder maintenance. Step 1 is setting up the directory. Create a new master folder on your computer. Inside that, create 2 specific subfolders. Name one Raw Sources and the other Wiki. We have to establish a strict boundary between these 2 folders. The Raw Sources folder holds your original PDFs, images, and articles. These are immutable. The AI is allowed to read them, but it is strictly forbidden from modifying them. To enforce that boundary, we need a set of instructions. We use a configuration file called schema.md, placed in the root directory. Notice the highlighted rule explicitly forbidding the AI from editing raw sources. This schema file is your standard operating procedure. It tells the AI exactly how your folders are structured and what formatting conventions to follow, turning a generic assistant into a disciplined archivist. Next, we need to help the AI navigate the wiki. Inside the wiki subfolder, create 2 blank text files, index.md and log.md. This diagram shows the specific Unix-style date format we will use for that log file. By keeping a rigid format, the algorithm easily splits the data, isolating the chronological date block from the action block, so the AI can parse exactly what happened and when. Because the AI is operating within this exact directory structure and following the explicit rules of the schema, it has a safe, contained sandbox to work in. It reads from a protected source and writes only to designated tracker files. Now that the architecture is built, let's test the ingestion workflow. Drop a sample document into your raw sources folder and type a prompt instructing your AI agent to ingest it. The AI reads the document, extracts arguments, and drafts a summary on the left, preparing database updates on the right. It immediately generates a wiki markdown page storing key themes, inserts a hyperlink into your central index, and appends a time-stamped log record. The AI executed that entire sequence, reading, summarizing, formatting, and cataloging, without you typing a single line of markdown. By typing one ingest command, you have moved an isolated piece of raw data into an actively maintained, interlinked knowledge base. Now we put that structure to work. Once you have a few sources ingested, prompt the AI with a highly specific question that forces it to compare your new document against a broader topic in your wiki. This mockup displays the critical command you need to append to your prompt. You must explicitly order the AI. Save this synthesis as a new page in the wiki and link it. Instead of disappearing into your chat history, the AI's answer becomes a permanent page. It visually connects previously isolated summaries in your graph, ensuring that every question you ask increases the value of the database. As you add more files and ask more questions, the database grows in complexity. To keep it organized, we use a process called a Lint pass. Once a month, prompt the AI to run a full health check on the wiki folder. Ask it to look for broken links, duplicate tags, or concepts that are mentioned frequently but lack their own dedicated page. The AI will scan the entire directory. It standardizes formatting inconsistencies and patches organizational gaps on its own. You don't have to manually audit your files. Through routine queries and automated health checks, the wiki stops being a static folder of notes. It becomes a system that actively compiles your ongoing research. Open your Markdown editor's Graph View interface. In just a few minutes of setup, you can see how those raw files have been structured into a clear, navigable network of ideas. Your text editor is the IDE. The AI is the programmer. Your knowledge is the codebase. To accelerate this process, you can install a web clipper extension for your browser. This lets you download online articles directly as Markdown text, funneling them straight into your raw sources folder for the AI to ingest. Find a template for the exact schema document we used today in the video description. Copy it, paste it into your root directory, and start building your own system. With the AI executing the cross-referencing, tagging, and logging behind the scenes, the friction of maintaining an organized database disappears. You are finally free to simply read, ask questions, and learn.